Before we discuss that, let's consider a quadratic equation. Say x squared is equal to 16. This is a quadratic equation because the degree of variable x is 2. Now, this means x is equal to square root of 16 or x is equal to plus minus 4 because square of plus 4 is also 16 and square of minus 4 is also 16. So we can say the roots or solution are, it's the roots of this equation, roots are 4 and minus 4. Consider another quadratic equation, say x minus 3 whole square minus 25 is equal to 0. Look, this also can be expressed x minus 3 whole square is equal to 25. And that means x minus 3 is equal to square root of 25. This can be written as x minus 3 is equal to plus minus 5. And this equation can be solved further. X minus 3 is equal to 5. That will give x is equal to 3 plus 5 or x is equal to 8. The other solution can be when we write x minus 3 is equal to minus 5. That means x is equal to 3 minus 5. So which is minus 2. Now you can see both these values of x, finally we can write together, x is equal to negative 2 or positive 8. Both these values of x will satisfy this equation, means these are the solution to given quadratic equation. So what did we see in both the examples? That the term containing x is a perfect square. Now, suppose sometime you have the equation of the type, consider x squared minus 4x plus 5. Say this is equal to 0. This is another quadratic equation, and we would like to solve this quadratic equation by completing the squares. If you compare these two terms with the a plus b whole square or a minus b whole square, you see that the middle term, which is minus 4x, right? So that should be, that means we can make it a minus b whole square. So to show that clearly, what we will do is we can take x squared, the 4x can be written as half of 4 is minus 2x minus 2x. And then we would like to add 2 into 2, half of that number. Half of this number 4 is 2, so we want to add square of 2. And we would also like to subtract the same number. Plus 5 was already there, equal to 0. See, what we have done is we have kind of split this 4x in two parts, minus 2x minus 2x. And then we are adding and subtracting 2 into 2 here and subtracting. So overall the equation has not changed. We have simply rearranged it a little bit. Now next we will take x common from the first two terms. We get x minus 2, and we observe that minus 2 is common from the second two terms. We get x minus 2 again. Minus 2 into 2 would be minus 4, and this is plus 5 equal to 0. Now look carefully what we are getting. This will imply x minus 2 is the first factor and x minus 2 again. So this part of the expression has been factorized. and the factors are x minus 2 into x minus 2, and this part will be what we have done. We have changed, look, we have made a perfect square here. So what we are getting from here is, that means x minus 2 whole square is equal to -1. Now what we have done is, we have changed this given quadratic equation into perfect square. So we find solution of quadratic equation using perfect square. Now how will we find solution of this quadratic equation? Obviously, because the square of x, look at here, the square of x minus 2 is negative, and we cannot find any real number whose square is negative. So therefore, we do not have any real roots. Consider another example. Now we take x squared minus 4x minus 5 is equal to 0. It's similar to the previous one. And now we will do the same thing. What we do, x squared, we split this into two equal halves. That is 2x and 2x. And then since half of 4 is 2, so we are going to add 2 into 2. And we are also going to subtract the same number. Minus 5 was already there. Remember, we are adding and subtracting this term. So overall, it is not having any impact in the expression, but it is helping us to convert this into a perfect square. All right. So minus 5 is equal to 0. Now we take common x minus 2, and then minus 2 common, again x minus 2. That's what we have learned in splitting middle term or factorization. This number is -4, this number is -5. Now this will imply, look here, we are getting x minus 2 as a common factor, and from here we are left x and 2, and these two numbers together, this was equal to 0. Yeah, minus 4 minus 5 would be minus 9 equal to 0. Now in this case, see, we are getting the similar situation as in the previous example, where we are getting the whole square of some number, and then is equal to 9. Now this thing can be solved when we have x minus 2 whole square equal to 9. We take the square root on both sides, and we get x minus 2 is equal to plus square root of 9. No, square root of 9 means plus minus 3. So that will give us x minus 2 equal to 3, or x minus 2 equal to minus 3. So this gives you x is equal to 5, and from here we get x is equal to minus 1. So therefore, solution or roots, whatever you say, roots of given equation will be x is equal to 5 or x is equal to minus 1. You can check also when you put x equal to 5 or you will put x equal to minus 1 in this expression, you should get 0. Let's check. When you put x is equal to 5, 25, minus 25, 0. And when you took x equal to minus 1, yes, you get 0 again, because this will become plus 1, plus 4, minus 5, 0. So both these roots satisfying our equation also. So we have solved this given quadratic equation by completing the square.